So maybe first of all, what is now the difference of pattern-based clustering algorithms to subspace and projected subspace clustering algorithms? Well, subspace clustering and projected clustering algorithms somehow look for clusters with a view on the data space. Yeah, so most of these algorithms try to explore patterns by exploring the data space somehow. So how the points are located in the data space. Pattern-based algorithms actually look at the data matrix and try to find patterns in the data matrix, which of course in turn correspond to specific patterns in the data space. But that's a completely different view of the things, obviously. Yeah? Patterns in the space, in the data space, where points are located, arranged somehow in the data space, and patterns in the data matrix. Yeah? So that is the basic difference. And pattern-based algorithms look for patterns in the data matrix. So let's see what is the general idea here. So first of all, we have a kind of overview here. We will see what kind of approaches do we have, what kind of patterns do we have, what kind of patterns can we explore in the data matrix. Those are the basic models here, like constant biclusters with constant values in rows and columns, pattern-based clustering like biclusters with coherent values, and biclusters with coherent evolution. So those are the basic models of patterns that can be found when looking at the data matrix. Yeah? And of course we will try to somehow translate that into spatial patterns, yeah? Patterns in the data space. Yeah? So we distinguish again between the spatial patterns in the data space and the matrix pattern. And later on, after we had a glance on these basic models, we will also look for specific algorithms, especially for constant biclusters, pattern-based algorithms, especially for and also for biclusters with coherent values. Yeah, let's just jump in and have a look at these different models. So once again, these different models actually define what kind of general patterns can we extract from the data matrix. Yeah, so pattern-based clustering algorithms relies on patterns in the data matrix, okay, and they somehow simultaneously cluster rows and columns of the data matrix. That's why it's also called biclustering. Yeah, so it's a clustering of two things simultaneously. Biclustering, clustering of rows and columns simultaneously. So first of all, we have a data matrix now called A, which has a set of rows, which is denoted by X, and a set of columns denoted by Y. Yeah, you see here a data matrix, so the X's are the rows and the Y's are the columns. Then AX, Y denotes the element in row X and column Y. Yeah, so here, for example, this guy here is, or here, this is AXI, so this is the value in row X and column Y. Yeah. Then a submatrix, IJ, has a specific subsets of rows, I, and a specific subset of columns, J. Yeah, so I is a subset of X and J is a subset of Y, the columns, the rows and the columns. Yeah, and this submatrix obviously contains those elements A, I, J, such that the rows are from I and the columns are from J. Yeah, so all the elements where the rows are from I and the columns are from J. That is a submatrix of the entire data matrix, obviously. Yeah, so you see here, so if J, for example, consists of Y and J here, and I contains of I and X here, then a submatrix, the submatrix AIJ, consists of the values I, Y, I, J, and X, Y, and X, J, obviously. Yeah, so the red color-coded elements here, the red color-coded values here are the values of this submatrix here. So you see that it need not to be adjacent elements in the matrix here. So a submatrix may also just define a subset of row column pairs actually, and they need not to be adjacent, as you see here. Okay, so the general aim of those bi-clustering approaches now is to find sets of these submatrices here, for example K submatrices here of the data matrix, such that each submatrix is a bi-cluster and meets a given homogeneity criterion. So basically meets a given pattern, or exhibits a given pattern. So here you see, for example, a very schematic, a very abstract representation of 3 bi-clusters here. A blue one which specifies those 3 rows here and those 3 columns, and then the green one which specifies 2 rows and 2 columns, and the red one specifying or defined by 3 rows and 2 columns actually. And the question is, what is this homogeneity criterion? So what actually makes a bi-cluster? What is actually the pattern that is allowed to be in those submatrices here? So that is the basic idea. And we just need some values that are often used by bi-cluster models. So the mean of some specific row I here is AI capital J, meaning that we sum up all the values in the specific row I over all the attributes or all the features, all the columns in J, and average that because we want to compute the mean. So for example, the mean of this row here for the red cluster consisting only of those 2 columns would be this plus this times divided by 2, and so on and so on. The same can be done with the mean of the column J. Now in that case we iterate over all rows in capital I, and sum them all the values in the specific column over all the rows in capital I. So you see here the sum, and of course normalize this by the number of rows in that case. So that would be, for example, the mean of this column here for the rows for these 3 rows here, which would be the mean of these 3 blue things here. So we sum up this plus this plus this divided by 3. So that would be the mean of this column here for those three rows. So the rows, the set of rows I, capital I, would be those 3 here, and the J here would be this column. And then also the mean of all elements of a submatrix. The submatrix is specified by a set of rows and a set of columns. In that case, okay, we just sum up all the values in all the row column pairs of the particular rows and particular columns, normalized by the number of all the values that we have, which is the cardinality of I times the cardinality of J, obviously, which runs down into the sum over all rows, row means, overall row means in this submatrix, and the same holds true with the sum over all, the normalized sum over all column means in this submatrix, obviously. So that is quite easy, and those values are often used because based on those values now we can decide what kind of homogeneity criterion must be implemented by these submatrices in order to be biclusters, and that's actually next.